entitled SuperMap AI Technology and Applications. To jumpstart our event for today, let us hear some opening remarks from Department of Geodetic Engineering Head, Engineer Gabino Hilvano.
Hello, good evening, good day to all. So to the speaker, to the participant of this event, to the guest, good day to all of you. My task is to deliver a welcome message on this activity. I am Engineer Gabino Silvano, Head of the Department of Geodetic Engineering Department of Eastern Visayas State University. It is a great honor that we have an opportunity to learn more about mapping technology. New technology is very much welcome to us. And every part of the community and society, I believe MAP is very important for information and education campaign, as well as dissemination. Maps is used almost every day from transportation, delivery of foods, and many others. It is also used for future planning and development for some communities. In the comprehensive land use plan for local government units, MAP is very important for its projected development and database information. This plan is needed as a basis for future development of a local community. In terms of research, before maps were used to identify the location of the study. However, today maps are used to extract information that can be used to derive conclusion in a research. Producing map, because of its wide use, is not limited to one profession only. It can be used by so many professionals as basis on its needs. New technology in map making is quite big help to those who create maps, especially the thematic map is highly needed. We are fortunate to have this opportunity that SuperMaps provide us new information about map technologies. We are glad that this opportunity were given to our university. I hope we learn more about the technology and hope that we can apply the said technology to our future endeavors. I would like to welcome you all to this great opportunity. In this case, I would like to cut short my message because of the time is so precious for the activity. But before I stop, I would like to say some big gratitude. I am very happy to the speaker and to the proponent of this activity to ensure that this activity is successful. I hope that we learn more from our speaker. I am very thankful to our speaker who provide their much treasured knowledge to us. Thank you very much. And again, I welcome you all. Thank you.
Thank you, Engineer Hilvano. We would also like to hear from SuperMap, top GIS software provider in Asia and one of the largest GIS platform manufacturers in the world. Here is a message from Evelyn Sun, General Manager of SuperMap Asia and Oceania Center.
Okay, thank you, Erica, and good afternoon, everyone. I'm Evelyn, the General Manager for SuperMap International. And I'm quite glad today to meet you all my fellow GIS technology and innovation enthusiasts. I would like to thank the whole Eastern Visayas State University, the University of the College of Engineering, and the Department of Geodetic Engineering for collaborating with us to present our company and the latest SuperMap technology today. I am quite pleased to welcome you all to this webinar, SuperMap AI Technologies and Applications. This is the second time that we have been doing this event, and we are tied up to a university in the Philippines. We are quite happy to impart you to the journey of SuperMap in the Philippines. In this virtual conference room, I would like to recognize the Dean of the college, the faculty, students, and other GIS practitioners, technologists, and innovators for joining us today. With your interest and enthusiasm, we can accelerate the process of transforming this world into a better place through advanced technology and innovation. So in this context, in this webinar, we will be discussing the latest SuperMap artificial intelligence technologies and its applications. And we will also show you a live demonstration of our software. I hope that after seeing and acquiring technologies and knowledge from the presentations today, you will grow more interested in the SuperMap technology and that a wider scope of people will be using our software. I'm confident that you will find new ideas with this application. So after all, I hope for more successful collaborations with more partners and universities in the future. Thank you. Enjoy the event.
Thank you, Ms. Evelyn. Moving on to the topics for today's webinar, we're going to have two presentations. If you have any questions while listening to the speakers, please feel free to type it in the chat box. The speakers will answer the questions in the Q&A session after the presentations. Our first topic is on SuperMap AI technology and applications to be presented by the Technical Manager of SuperMap Asia and Oceania Center, Mr. Jason Yuen.
Okay, good afternoon, everyone. This is Jason. You can see my screen, right?
Yes, you can see it, Jason.
All right. Good afternoon, everyone. This is Jason. I am the technical manager of SuperMap Asia and Oceania Center. Today, I'm glad to be here to share the SuperMap AI GIS technology with all of you. First, please give me a few minutes to let me introduce SuperMap as a company. SuperMap was founded in 1997 under the support of Chinese Academy of Science, and the founder of SuperMap is Dr. Zhong Ershun. As we know, SuperMap is the only one GIS platform provider who got listed in stock exchange market. And we already have more than 38 branches and offices in China and overseas. And currently, we have more than 4,000 employees. And this one is showing the annual revenue of SuperMap from 2015, 2014 to 2017. And we can see that the revenue of SuperMap grows steady, and it is almost 3 times of 2017. I mean, comparing with 2014. And since 2015, SuperMap already been the biggest, already got the biggest GIS market share in China and Asia. We have more than 700 partners over the world. And currently, our technology has 5 features which make SuperMap different with others. They are BITDC. The BITDC means Big Data GIS, AI GIS, 3D GIS, Distributed GIS, and Cross-Platform GIS. And today, we mainly focus on in the center, the AI GIS. So what is AI GIS, or what is the core values of AI? First, the Industrial Revolution, it liberated human from repetitive physical labor, but the AI liberated human from repetitive mental labor. So the SuperMap AI GIS technology system is like this. From the bottom, which is the most basic one, is the data, and the library, and then the framework. Based on the basic data library and framework, we mainly provide 3 types or 3 parts of functions. They are GeoAI, AI for Gis, and GIS for AI. So next, I will follow the order of this diagram to show you the SuperMap AI GIS technology one by one. So the first one is the data. The data is the most basic unit in the GIS, in the AI GIS technology. It has 3 types: the file data, the relational data, and the NoSQL data. And then it is the library. The library has the original library, the sample library, and model library. The original library stores the raw geospatial information data, such as our satellite image data, such as our raster data. They are all stored inside of the original library. And after the data cleaning and the preparation, it can go to the sample library. The sample library is the ready data or ready library to be trained as a model. Then we can got the model which is inside of the model library. The model library has two types, the model file and the model parameters. They are stored as the code or as some model file in the library. And the upper level is the framework. Talking about AI technology, there are a lot of popular and professional and advanced framework in AI industry, such as Spark, such as TensorFlow, like Keras, like PyTorch, and in the traditional way to use AI, the user always need to think about what kind of framework I want to do. I need to based on to achieve my requirements. And we can easily say that every framework has its own features, such as the Spark is good at distributed machine learning framework. It is a distributed machine learning framework, and it can support different operators. And the TensorFlow support is good at the other operators. So the framework is very important in the AI technology. And but how to choose it? I can tell you that don't worry about it. SuperMap already help you to choose from the framework for different functions, for different analysis. We can automatically choose the best framework for you. Okay, and the most important one, and also the last one, it is the functions. So based on the data, library, and framework, based on the traditional AI technology, what we can do in the GIS industry. This is the topic we need to discuss today. So the functions has divided into three parts, the GeoAI, AI for Gis, and Gis for AI. So I will introduce you one by one to you next. So the first one is the GeoAI. The GeoAI is from AI to GeoAI. Actually, we mainly use the AI technology, the AI capability usage in the geospatial aspect, such as the statistics. We use the in the Gis industry, we upgrade it to spatial statistics, like the machine learning to geospatial machine learning, the deep learning to geospatial deep learning. So first, what is the spatial statistics? It is study and analyze spatial data and problems based on statistical theory. And because of the spatial properties of spatial data, such as spatial autocorrelation and spatial stratification, heterogeneity, and also it is necessary to analyze the overall characteristics of space, spatial interpolation, spatial pattern, and spatial regression. There are some operators we supported, we already achieved based on the spatial statistics, such as the geospatial distribution characteristics, the geospatial pattern and regression, the geospatial interpolation, the geographic sampling, and geographical distribution. And here I choose one of the case, which is the environmental factor identification affect spatial pattern of disease. Here we based on the statistic capability and overlay different layers of spatial data, such as the disease indices, the watershed zoning, the soil type, the DEM, and based on the statistical to do the affect spatial pattern of disease analysis. And next one is the spatial machine learning. The spatial machine learning is a series of methods to analyze spatial data using machine learning models. The spatial features of the task need to be embedded into the machine learning feature calculation process. And many machine learning modules are involved, such as spatial clustering, classification, and regression. There are some operators of geospatial machine learning, such as clustering, like the hotspot analysis, the spatial density clustering, and the classification, such as map matching, logistic regression, gradient boosting classification, and others. And the third type is the regression, which is like the geographic simulation, the linear regression, and others. So this is another case. This is an estimation of housing price impacted by infrastructure. We choose the variables from transportation, such as the bus station, the main road, and the second one is the education, and then also the medical service. We based on these three variables and also each own location information, the positions of every housing, to estimate the housing price in Beijing, and got the result which is very similar to the real situation. And another one, this is the crime analysis, crime estimation based on the spatial machine learning. From the first one, based on the forest-based classification, we can get the crime rate or crime location, and based on the support vector machine classification, we can estimate the crime type. And based on the hotspot analysis, we can estimate the crime hotspot. And next, another operator is the map matching or road mapping. This is a new feature in our latest version of our products. It is based on machine learning model, calculate the reasonable matching of the trajectory points to be matched and restore the real trajectory. And the import data is the trajectory points, and the model is hidden Markov model. This is a very common used tools in our projects, such as when we want to track the GPS points of a car or of a vehicle. The GPS points always has some offset, so we need to put it into the road to match the road. And if we use the traditional way to match the road, we always like find the trajectory point and the nearest road point and put the point into the road. But that one has a lower accuracy. And this one we can see the green dot point is the GPS point. And based on the GPS point, we can match it into the road network based on the hidden Markov model. And the accuracy is reached to 97%. And the second subtopic of GeoAI is geospatial deep learning. Sorry, the third subtopic. The geospatial deep learning is a method to analyze spatial data based on deep learning module. Through deep learning module, multi-dimensional fusion, correlation analysis, and in-depth mining of complex spatial temporal relations are carried out. At present, deep learning modules such as the CNN network are widely used. So there are also I listed the operators of geospatial deep learning, such as graph analysis, the spatial temporal prediction, the 3D data analysis, and image analysis. For example, this is an object detection based on a CCTV video. This is to detect the safety hatch. And another one, which is which is based on the picture, based on the photos to do the object detection, and this is to detect the traffic sign like this, and like this. So they are all the traffic signs. This is to detect based on the photos. And some others like graph classification. This is one of our real projects, which is to help the worker to identify the electricity meter. And there are 3 types of electricity meter. Well, first we need to recognize the type of electricity meter, and then to read the number, read the value on it. And this is already used in a real project. And another important operator is the graph time and space regression. It is the regression calculation for points and to convert spatial temporal data into sequence signals on the graph. And the input data is the point. The module is used the GNN network, the GNN module. Let's take a look at it. This is one of the keys to predict the traffic based on GNN, based on the graphic neural network. And this is to predict the traffic situation in 1 hour later. And the prediction accuracy can reach to 92.7%. So the traffic department can, based on this feature, to predict the future traffic situation. And others like the object detection. This is also one of our real projects in Indonesia, and our customer need to detect the objects, detect the palm tree. They need to, based on the image data, to get how many palm trees I have. So based on the object detection, we can detect all the palm trees, and even we can detect the tree which not grows very well. And next operator is an instance segmentation, the object extraction. That one is training neural network based on image and simple data and used for instance segmentation of image data. Here I will give you an example. For example, for the object extraction, we can extract the objects from the image data and make all of the objects independent. And for the details, if we also can use the object detection to get it like based on the binary classification. But we can see there are some of the objects are connected to each other. The result is not good, it's not very good. But based on the instance segmentation, which is the object extraction, it's not the object detection, we can make every object independent with each other, and everyone has a clear boundary. And another one is to extract the footprint from image, such as and based on the binary classification. And we can extract the building on the left side image data and extract them as vector data as right side. Okay, and now we are going to the second topic, which is the AI for GIS. AI for GIS is the basic is the GIS function, but AI can bring some enhanced function to help GIS evolved, to help GIS improved. And there are many 5 features of AI for GIS. They are the AI attribute collecting, AI measuring, AI survey and mapping, AI interaction, and AI plus AR, which is the new one. And we can say the AI attribute collecting, which is based on the camera detection by the photos or by the camera of mobile phones. So we can use it to detect the objects, such as to detect the damaged roads, detect the rubbish bin, detect the ads, detect the messy materials, and after detect them, we can submit the report on using our mobile phone, directly submit it with the location of this mobile phone to the center, to the cloud, and the administrator can get them easily with the objects, with the position, and with the videos. And also the indoor and outdoor AI measuring, such as this is based on the camera of our phone to measure the big area of things, such as in the market to measure the height. And when we do the outdoor survey, we can based on it to measure the building and very easily to upload this graph to the building. And this one is and next is also the point cloud measuring. And this one is also based on the CCTV camera to collect the point cloud indoor. Sorry. Oh, yeah. And the next function is AI cartography with style map region. Such as the left side is a style picture. We can choose it as whatever we want. And on the right side is the original map. Oh, sorry, what is that? Yeah, and on the right side, it is the original map. Then we can extract the main color by k-means module from the style picture and extract the main color from the original map, then match them together and to give a new style of the original map. Such as we can see here, this is Vogue with map and as in Photoshop. We can easily choose one style of picture and do the mapping styling very easily. Also, next, there are some smart recognition of hand gestures. For example, we can based on our body gesture to control the GIS scene, such as the pan, such as zoom in, zoom out, pan, and click. And also we can rotate the camera angle based on our body gesture. And also it can be done on the web, like we can use our body to control the map rendering, control the map view. Sorry, my PowerPoint frozen, it seems. Yeah, let me play it again. And the last one, which is AI and AR, this is a new function. Yeah, this is a new function, and based on the AR, we can detect the objects based on the camera, such as we can develop the mobile app, and based on AR to detect the logo, and to detect the fair facilities, and also the bench, the road, the flower, the vehicle. So it is very convenient for the worker to do the operation and maintenance for a park. Yeah, such as the road lamp, the vehicle, the flower. For every object, we can use AI and AR to detect them and get the attributes of them. And also the projection can be done, such as we can in the market, in the mall, we can in the camera we can put one web page on it, and we can easily go through the goods in every store. And also we can put the video on it, such as we go to the Zara, and we can easily post a video of this store. So this can be developed to a mobile app as a AR app to go through to help the market do the marketing. Okay, now go to the third part, which is Gis for AI. And Gis for AI is based on the AI technology. We use the GIS functions to improve the AI capability, such as the traffic monitoring visualization, the spatial visualization for AI. The main function is done by AI, such as on the camera detect the car. We can see on the right bottom corner in the video, it detects every car and also get the situation of traffic. Then in GIS, we mainly put them on map and show the heat map based on the results of AI detection. And this is the real-time AI vehicle recognition platform. Based on the AI camera, it can detect the vehicle's type. We can see on the right side the statistics, and also we can draw some polygon on the camera, such as on the yellow side we can see the yellow polygon. On the left side we can see the yellow polygon. This is a busway, and it's not allowed the other vehicle like the normal car to go through it. So we can get the illegal vehicle from it, like the motor vehicle and non-motor vehicle. And it also can be used by the dig vehicle tracking, which is the dig vehicle means like two cars they are using the same number, same ID. So in the system, it can easily detect the number of car and show the position. Once they found that it is impossible, like from one point to another point, it's almost at the same time, but using the same number, then that means they are the dig vehicle. Okay, as a summary, let's take a look at the AI Gis technology system again. The basics are data, library, and framework. And based on them, we mainly provide three types of functions. They are GeoAI. The GeoAI has the geo machine learning, geostatistic, and geo deep learning. And the AI for Gis, it has the AI with AR, and AI attributes collection, AI measuring, and Gis for AI it has the spatial visualization for AI, spatial analysis for AI. At the end, let me show you the AI product system. For the AI framework and the GIS object, we have the SuperMap I objects for Spark and SuperMap I objects Python to provide the core capability. And on the cloud side, we have the SuperMap I server and iPortal to provide you the cloud capability of AI GIS. And on the terminal side, we have the SuperMap I desktop apps to handle the whole workflow of GIS of AIGs, and also we have the web terminal, iClient, web apps, and iMobile and iTablet to achieve the AIGS functions. And this is the AIGS products function matrix for the different types of operators which products supported. We can easily find it here. And the last one is a SuperMap AIG's hardware configuration reference scheme. And this is the recommended environmental reference for to run AIG's software. Like the method, like the GPU better use the NVIDIA, and the CPU better use like the Intel E5, and also the ROM, the disk. We already listed them here. Later, we will share the PowerPoint with you, and you can take a look at it in detail. All right. So this is the summary of the our technical system, and today we mainly focus on the AIGIS. And the SuperMap Gis 10i product system is like this. In the cloud, we have the Cloud GIS Center, which are SuperMap I Server, SuperMap I Portal, and SuperMap I Manager. And on the terminal side, we have the terminologies for desktop, such as iDesktop X and iDesktop. And for components, we have different coding language iObjects. And on the website, we have iClient, JavaScript, and iClient 3D for WebGL. And on mobile side, we have the iMobile as the SDK and iTablet as a mobile application. And on the edge side, the iEdge is mainly used to enhance the service performance. Thank you, everyone, for your time. You can please feel free to address your questions in the Q&A box or in the chat box, and we will answer you in the end in the Q&A session. Thank you.
Thank you, Jason. Pretty cool, right? Lots of applications jam-packed in that presentation. While you're letting all of that sink in, maybe you can also start asking, how can this kind of technology be utilized in my field or industry? We're excited to hear about what you come up with, and we're very much open to collaborating with you to make that happen. Again, if you have questions about what Jason just presented, anything about the BitDC technology of SuperMap, please head to the Q&A chat box below and our technical team will answer them. For our second and last topic, our technical support engineer, Jin Zhang, will be showing us a demonstration using SuperMap AI technology.
Good afternoon, everyone. This is Qing, a technical support engineer in SuperMap Asia and Oceania Center. Today, I'm so glad to be here to have a chance to share my topic to you. My presentation is about the SuperMap AI GIS workflow based on geospatial deep learning. My presentation has three parts. Firstly, I will briefly introduce what SuperMap AI GIS technology based on geospatial deep learning, and then I will introduce the detailed workflow of AIGIS, and the last part, I'd like to demonstrate how to journalize airplane detection using SuperMap AIGIS. So let's firstly talk about the SuperMap AIGIS technology. As Jason just mentioned, SuperMap AIGIS technology includes three parts: Geo AI, AI for GIS, and GIS for AI. So for this topic, I will mainly talk about the Geo AI, which based on the geospatial deep learning, and I'd like to discuss with you about the workflow of the Geo AI. So firstly, let's take a look at what algorithms are based with the geospatial deep learning. In the geospatial deep learning, we're mainly based on the AI algorithms such as the semantic segmentation, instance segmentation, object detection, and others. With these AI algorithms, we achieved the Gis functions, such as the binary classification, multiple classification, object extraction, object detection, and the scene classification. So we have the functions of based on the geospatial deep learning. So what can we do with these GIS functions? Here, we can see that with the binary classification, if we want to extract buildings or roads, so we can use the binary classification. And if we want to apply for the land-use classification, so we can use a multiple classification. And for the airplane, boat, cars detection, and other objects detection, or we can use both object detection and object extraction. And also we want to apply for the classification of local climatic regions. We can use scene classifications. So then let's take a look some examples of this based on the GIS functions. So as you see that this is an example about the palm trees detection, which we can detect every palm tree in the imageries, and also with the result we can get the number of the palm trees. And also we can extract the buildings based on the binary classification. The binary classification uses unit structures of deep learning algorithms to classify a certain kind of ground features in imageries. And also we can achieve the land use classification based on the multiple classification. Similar with binary classification, multiple classification uses a neural network model to determine which type of interest each pixel in an imagery belongs to. So we can classify different types of objects, and at the same time as the just like the picture shows, we classify the building, fields, the water, farmland, forestry, and others. And also we can for some high density objects, we have the object extraction, just like the photovoltaic panels extraction. We can not only detect the photovoltaic panels, but also we can extract the control of the photovoltaic panels. Then the next, I would like to talk about the detailed workflow for the AIGIS. There are 3 steps of the AIGIS workflow. The first step is data acquisition and preparation, including acquisition, storing, and processing the data. And the second step is model building. The model is also generated by training and evaluating, also converting and updating. This is a process of many iterations. And the last steps, we can prediction using the well-trained model or publish the model to the server. So firstly, let's take a look what SuperMap products supports the AIGIS workflow. Firstly, it is the SuperMap objects Python, which is a component GIS, supports the whole processing AIGIS workflow. And the second tools is the SuperMap at Desktop X, which is a desktop GIS, also provides the whole processing workflow of AIGIS. And the third one is the SuperMap as Server Data Science Service, which also provides the whole processing workflow. And the last one is the SuperMap as Server Machine Learning Service. This service can only provide the model application. Also, we need to firstly get the well-trained model from the previous 3 tools. Then let's take a look at what SuperMap objects can provide. SuperMap objects can provide. There are 2 SDKs for objects can be provided. The first is the SuperMap objects for Spark, which can provide the deepener, the distributed machine learning and the storage management of distributed sample library. And the second one is the SuperMap object Python, which provides machine learning toolbox, and also the which can also provide the deep learning related functions and the whole processing workflow of deep learning. And this is SuperMap desktop product, SuperMap at Desktop X. As I mentioned, it also provides the whole processing workflow, sample generation, model training, and application. And the next tool is SuperMap as Server, which also provides 3 classes services: distributed analyst service, machine learning service, and the data science service. Distributed analysis includes distributed vector spatial analysis, related machine learning operators, distributed grid space analysis functions. And the machine learning service focuses on the provision and display of spatial deep learning related capabilities, including publishing the well-trained models to the web services and providing AI GIS capabilities. The data science service integrates SuperMap spatial data science database and third-party data science modules in Jupyter environment, which can support the workflow ability of deep learning and related spatial deep learning functions. Data science service of SuperMap as server provides objects and client Python libraries. In addition, a third-party science library are also built in. It also provides a visual notebook editor interface for users to build operation of AI GIS workflow. This is a data science service. We have wrote the whole processing in the notebook. And the next is about the SuperMap as server machine learning service. As I mentioned that the machine learning service provides the the well-trained model publishing and application. So firstly, we should use other tools to train the model, and finally get the well-trained model, then publish the model to the AI server. Then we can further apply for the use the model to prediction or reasoning. So this is an example based on the SuperMap as server machine learning, which can generate the object detection, binary classification, and multiple classification. Then let's take a look at the whole processing workflow of AIGIS. As I mentioned that there are three steps. The first step is the data acquisition and preparation. In this step, we need to prepare the imagery data and the vector data, and you also need to know which objects what interested area you want to detect or classify, and then we can get formalized data through the data training tool. The formalized data can be divided into three parts for the second step, model training. And we also know that the model training is a learning processing. So it takes time, but to get a well-trained model until the well-trained model can be only got only when the model meets the accuracy requirements. So first, through the, when the model training finished, we can further use the model to publishing and or for application. And also in the SuperMap 10i 2020, we also provide the post-processing tools to further improve the prediction results. So let's first take a look at the first step, data acquisition and preparation. So the first we need to prepare the sample data. The data we can also get from the common training data samples, such like the ImageNet or UCMerged nanos, or we can make the training data by users. So you can based on your application or purpose to make the samples and take we also take the palm trees as an example. Here we want to detect the palm trees, so we first prepare the imageries, and then we need to draw the contour or draw the contour of the palm trees as sample data. So here with the original image or the imageries and the labels we made, we can use the data training tools to formalize the data. SuperMap also provides two tools. First, we can use the web tools such like the data science service, and also we can use the desktop tools to finish this step, and finally get the formalized data. So you may wonder, oh, you already have the imagery data and the sample data, why we need to train the data again. Because you know that you may know that the volume of imageries is often large, and the convolutional neural network has high requirements for running memory. So the imagery need to be processed into data suitable for machine learning model training. The purpose of create training data is to simultaneously cut the image data and the label data into small pictures and generate data suitable for neural network model training. So this is a formalized processing. Here is the training data production used SuperMap at desktop X, and this is the tools of data science service, which with the codes. And for this second step is the model building and management. The model in this step, we are the model construction and management is to train neural network model based on the training data generated in the process of data preparation. AI framework and the neural network tests set to meet the requirement In this step, the data we know that the data, the training data are divided into three parts. One part is for training and one part is for validation, and the third part are for testing. So the model training firstly based on the CPU or GPU environment, and with the AI AI framework such like the TensorFlow, Keras, PyTorch, and also based also we based on different operators, that like the if you are if you are doing the object detection, it is also often based on the faster RCNN algorithm. Then with this progress, then when we finally get a model with SDM format. So again, the model building can also be operated by SuperMap at desktop X or using data science service. During the model training, we also need to consider when the model is well trained. So with the tools, we already have the tools which can achieve the model training, but how we know that whether the model is well trained enough for inference? So there are some indexes to validate the model, such as the IOU, kappa. The IOU is an index that calculates the coverage of intersecting regions and combined regions. And we also validate the models through statistics, the number of identified objects, such as accuracy, recall, and the FE code. Accuracy is a common indicators to validate the correct results, such like the examples. There are 10,000 target recognition objects, and the identified objects through LU verify is 9,000. So we can get the accuracy. And also the recall shows how many examples in the sample are predicted correctly. But we know that it is hard to get high accuracy of the both. So we use FE code combines the results of accuracy and recall. When the FE the value, the FE score is higher, the result is the model is trained better. So after a long learning progress of the model training, we can finally get the model files with SDM model and the PB formats. So then, well, after we got the well-trained model, so we can use for the model application. So there are also there are also three tools at desktop X. The desktop tools to application, and also we can use a server data science service. Also now we can use a server machine learning service to publish the model, and also do the application. Oh, so this is the final model inference using SuperMap at desktop X, and this is achieved by the model inference achieved by machine learning service to get the buildings. So after we get the predict results, we often need to the post process the results because the image classification or extraction may contain many small misclassification or wrong pixel regions or other errors, just like the middle picture shows. So we need, so also SuperMap desktop provides data post-processing tools such as model filtering, boundary cleaning, expansion, refinement, and other tools which can be used to improve the accuracy for the further application. So this is example about the binary classification. We build the whole processing and we firstly realize the binary classification and do the post-processing of including the expanding the rows and shrinking the results, and also convert the grid result to the vector data. So we finished the theory of the AI GIS based on the geospatial deep learning. So in the third part, I would like to show a case and demonstrate you how to detect airplane by SuperMap at desktop X. So here I prepared two imageries. The first one, the one is for training, and the next, another one is for the inference. I also prepared the labels, which match the imagery, the first imagery, and they are the contour of they are the rectangle of the airplanes, and then we're using the object detection to get up to first need to get a model and then use the model to predict the another imagery. So now I will go to our SuperMap at desktop X. Now here, this is the SuperMap at desktop X interface. Here I already opened the three data, the label data, and the one imagery, the imagery for training, and the another imagery for prediction. And here I also add the label. We draw the rectangles of the airplane. So we are going to use these two data to get our training data. As I mentioned before, there are three steps. So the first step is data preparation. Now we finish it, and the next we are going to find the machine learning tools. We can find it at the toolbox and machine learning imagery analysis. Here we can see there are whole processing tools, including the create training data, model training, object detection, binary classification, multiple classification, and others. So the first we are going to use to create the training data. Here we have several parameters need to be set. First, we select the sample image, which is the plane, and the sample tank, the samples, and the picture size. The picture size is what I mentioned. Finally, the whole imagery will be divided into the picture size we set. Just here we set at 640, and then we are going to select the training algorithm, the data, the deep learning algorithms, like object detection, binary classification, and others. Here we select the object detection, and the class field. Here we can check the label. Here we only have the airplane, the plane to detect. So there is only one catalog. So here we can also we can select the new field, or we select none. And then we set the result data output parse. New folder. Finish it, when we finish it, setting the parameters, then we can click run. Then here we can find that when we run the processing, there are some information output to the Python box. Here we can see the information that the create training data have done. Under this directory, here we can go to the directory to find the result of the data training. Here we can, there are some folders created by the result. And here we can see that the imagery are finally divided into 47 small pictures. And we can check the attributes, and here the picture size is what we set. And also the results also divided into the test part, training part, or validation part. So when we get the result of the data training, we can continue to train the model with this result. So here we select the model training, and then we first save the training data parse. This is what we get from the first step. We select the whole folder, and then here we select the training model usage. We are going to use the object detection and the training config file. The training config file is under our resource our resource folder, which you can download from our official website. Here we can find the trainer config folder under the under the resource, and find the object detection. If you are doing binary classification, you should choose the binary classification configure file, and here we check the object detection tree configuration file. And then the next we need to set the epoch, which it is the number of the training times. You can understand the training times. Here the default is 10, and usually we know that the model training is a learning process, so it is long processing will often we should based on the accuracy to determine if the model is well trained, and if it is not meet our accuracy requirement, we need to end the training times. Suppose we need to train and much more 20 or 30 or 30 times. And also if you the times you set more, and the learning progress for processing will be much longer. And the next is the bench size. Here we can also set it at default, and the learning rate, which it is also you can understand it as experience value. Here for the object detection, we can set it as 0.0001, and then we set the parts of the training log and the model output model. Here, you are folder to store the model. And here we also set the output parts of the model. Then after we set this, we can run it. But in this presentation, I will not run it because, as I mentioned, it will be a long time based on this training times. So here I just we will just use a well-trained model, which and do the third step. So you can understand, you can know that the model training in this step you can only set those parameters and run. Then finally you can get a model. After you the final model, here we are going to use the model we trained before. Here we can see this is the model we trained before, and this is the result of the second step. Also, then let's continue to go to the third step, the object detection, the prediction. Then first we need to select the injury we want to detect. we select the plane infer, and then parameters we select the model file. Here, select the object detection plane, the SDM, and then we can set the result. Let's run it. Here we can see that there are new data sets generated by this by the running, but it is still running and it is not finished. So we can just wait. Okay, I think we can check the results. First thing we and the inference imagery, and we end the result to the current data. Let me change the layer style. Results. So here we can see the plane on the another imagery will detected, and here so we can also check the attribute table of the results. Here we can know the final the numbers we detect. And this is for the desktop application. So we can also try another of AI functions. You can download you can download the iDesktop X and the AI AI environment from our website. The next, I also want to show you how to publish the well-trained model to the server. Before our webinar, I already start up iServer, and this is the homepage of SuperMap iServer. Then I would like to show you how to publish the well-trained model through the iServer. So here we firstly go to the manager of SuperMap iServer, and yeah. SuperMap iServer provides a method to publish your data or map to the web. And here we publish the machine the model we trained. We're going to find the clusters and data registration, register data storage. Here we can we first data storage type. Here we can there are distributed tile and big data file share, spatial database, machine learning model. So here we are going to publish the model as machine learning service. So here's the machine learning model directory. We are going to find the model directory. And register data storage. So now the model is published on the server. So then we can use the server to do the prediction or reasoning. Here we are going to the services and find the service management machine learning service. Here we can see their machine learning service lists. We can find the binary classification, multiple classification, object detection, and others, and also some statistic tools. Here we will also use the object detection to detect the airplane. And first we input the data source, the image we want to detect. Here we find the object infer and the dataset name infer, and the model file. We select a machine learning model. This one is I just published a category name is name, and the score trace we can keep it at default. And here we can custom the output data source and output data source name. Here we can keep it at default. And after for the server, we can not only returning the results, but also we can publish the results as map service or data service at the same time. Here we can check it to see what the results should be. And then after when we finish this setting, we commit. Here it will take a second to finish the detection and the publishing. So here we can just be patient and wait until it finishes. Yeah, it another success, and it is publishing. And during this time, I think you can go to our SuperMap official website to download our desktop products, desktop X, and also the deep learning tools under the objects. Objects, Python environment, resources, and the GPU environment for the AI application. So it had done. So here we can see the then we can check the results of the map service and data service. Here we can view the map. The airplanes are all detected, and at the same time they are the results published to the server, so we can do the further web application. We can also check the data service. We can check the results. The object detect. So not on the map service and the data service can both for the further application of web, and also the results also stored. There are workspace also stored in the local at the local. So we can find the results under the sorry. It's the output folder, machine learning. So here we can see the results also stored in your local disk. And here we can also open it to check the results. Here we can see the workspace. There are results. The final airplane detection results and the maps are also saved in the workspace. Because we also start up the server, so here we can only check we can only check the results in the data source. So I think we finished the airplane detection and let me summary make a summary for this presentation. Firstly, I introduce the detailed workflow of AI Gis based on the geospatial deep learning, and then we I demonstrate how to realize the airplane detection using SuperMap at desktop X, and how to publish the real-trained model to the I server and detect the airplane using SuperMap I server. So I think that's all for my presentation. Thank you. If you have any questions, you can leave messages. Thank you. Have a good day.
Thank you, Ms. Chin, for that live demonstration of the SuperMap AI technology. There we have it. Our technical team just gave us a comprehensive introduction to SuperMap AI GIS and demonstration. We hope that by this time it is bringing you some new ideas on your current projects, research, or business. While the presentations were ongoing, we have actually answered some of your questions already. But in case you would like to ask more, feel free to type in your questions and our technical team will answer it now.
Okay, this is Jason. So I think I can answer the questions in the Q&A box. The first question is, are there programs or websites that can give me data without drawing on the ArcGIS program? First, I want to say, like drawing the sample data, we suggest you to use the SuperMap program, such as SuperMap iDesktop, iDesktop X, and for the AIGS, for the AI model training, it has to have the sample data as the basic to train the model. So I think there's no programs or websites can provide you the data without manually drawing it. Because I know that there are some common used module in where you can find it in some websites, but for different types of image, we need different types of samples, because the image has a lot of differences, like the color, like the feature, like what type of feature you want to detect. So for for every bunch of for every series of image data, we always need to use the corresponding sample data and to train the corresponding model. Okay, and the second question is for object-based detection, spatially spatial factly tree detection. How can the program separately detect trees in a cluster, or will the software read a cluster of trees as one tree? First, I want to say if we need to detect the tree which are in the cluster, such as a forest, in this case, it's not suitable to use the object detection. We suggest to use the land use classification, the classification based on image data, because the software, as you said, the software cannot separate the trees in a cluster. So it will detect the tree cluster as one area, and always in this case, we don't need to detect every tree. We just need to detect the area of this cluster of tree. So using the classification will be better. And next, in object segmentation, is there any need to select several training samples? Yes, we suggest to use as much as we can get the training samples, because if there is more training samples, the accuracy of the model will be higher. But usually we just need one training sample with enough area is enough, is okay. Okay, and next question is, what is the required resolution of image go be able to extract or generate building footprint? For this one, we suggest the resolution is less than 1 meter. Based on our experience, if we have the less than 1 meter image data, the result will be very good. But sometimes we cannot get this high resolution of image data. So if the requirement of accuracy is not so high, we can also choose the resolution like 5 meters. Around 5 meters is also can be used. All right, next question is how SuperMap can be helpful in the field of civil engineering. Yes, we have the solution about civil engineering part, but it's hard to show them here, and also it's hard to explain them in a short time here. Maybe you can contact us by the email or by the phone, contact with us directly. I think we can discuss this further later. Okay, and next, is there a mobile app for SuperMap? Yes, we have the SuperMap tablet, which is including the AR and AI functions. And also there are some basic GIS functions such as serving, such as mapping and spatial analysis. It also can show the 3D scene. If you are using an iPhone or iOS device, you can download it from the App Store. You can just search SuperMap tablet, SuperMap tablet. And if you are using an Android device, you can download the APK file from SuperMap website to take a look at the SuperMap tablet. And next, can you suggest sites where we can download high-resolution image for free other than Earth Explorer platform? Sorry that as I know personally, I don't know any website which can get the high resolution less than 5 meters. Yes, I know that the AI technology always requires a high resolution, but this kind of data always provided by our customer. SuperMap don't provide the data either. Okay, next is we are only using lower version and cheaper laptops. Can this software still run smoothly, like for example, processing high-resolution images and large data size, or does it need laptop PC with advanced specification? We said in the end of my presentation, I put one specification of hardware there, and it is, yes, it is a quite high specification. But actually, if you don't need to use it for a real project or for a big project, a normal PC or normal laptop also can be used, but it should be a higher specification laptop. Such as my laptop is it has 16 GB memory and Navig GPU RTX 2060, and my laptop can run the software and also can run the AI functions smoothly. And of course, lower is also okay, such as 8 GB and maybe Navig 1060 GPU card. It also can run. I suggest that rather than worry about your laptop or PC is enough or not, I think you can try to download SuperMap products on your laptop. It's free. You can download it and to try it first. Then you will get the results whether my laptop or PC is enough to run AI or not. Okay, and next one is I have one question about traffic prediction based on GNN. This function can analyze it about transport energy consumption on street and display like this, or please recommend the solution for these programs. Yes, this prediction case is based on the GNN, and the input data of GNN is just the point, the changing of point, and based on the changing of point, we predict the future traffic situation, and also as you said, it is based on the road network and display it on map. For the detailed solution, I think you can contact us and we can discuss later further. Okay, and in order to use deep learning module, is it necessary to have SuperMap iDesktop as well as the iObjects pattern library? Yes, we need. If you want to use the deep learning module, you need to use the SuperMap iDesktop X. Yeah, please notice that it is the SuperMap iDesktop X, and also you need to download the iObjects pattern library to work together with iDesktop X, as my colleague Chin showed just now. All right, can I use SuperMap X on Windows 64 while I also have SuperMap 10i 2020? Yes, the SuperMap iDesktop X and iDesktop can work together in the same PC, and you can just download it from the website directly. Okay, next one is, what is the use of this app in the field of electricity, particularly by electrical energy? What is the use of this app? I'm not sure whether you mean the mobile app or the SuperMap products, but if you are looking for a solution, yes, we need to use. I think you can, as the same with others, you can contact with us and we can discuss the solution in detail. Okay, and next, do you consider SuperMap as a user-friendly application, or is there a skill level specifically in using the application itself? I think, as we explained earlier, SuperMap products provide the whole workflow from prepare the sample data to the training model and then to the model application. We provide the whole workflow in the software, and it doesn't require any code. So So there is no any skill requirement about programming to use SuperMap products to run the AI functions. But of course, it needs some skill, some knowledge about such as GIS, about AI, some basic knowledge. But it's very easy to learn. You can follow our tutorial and use your own data to achieve what you want very easily. Okay, I think that's all of the questions. Thank you, everyone. Thank you for your time.
Thank you, Jason. That's it for the Q&A session. If you have more questions, you may also message us. We can see from your questions that this webinar has sparked your curiosity about SuperMap. Because of that, we are happy to announce that we will be offering a free trial license to our participants here. Just send us a message or an email as you can see on the slide. To cap off our event for today, let us hear some closing remarks from Dr. Annabel Pilapil, Dean of the College of Engineering.
Good afternoon. My respect to the dynamic General Manager of SuperMap Asia and Oceania Center, Ms. Evelyn Son, the equally talented Technical Manager, Jason Yuan, to the energetic Technical Support Engineer, Kin Zhang, and of course, to the Business Development Team of the Philippines, organized by Madams Erica, Emily, and Celine. To all participants of this SuperMap AIGIS training, a pleasant afternoon. It is indeed a privilege to all those who attended this lecture and presentation to learn on GIS and the latest technology that would be of great help in the conduct of actual work related to the profession. I do appreciate all the lecturers who presented well and came up with a very impressive lecture. And may those who are logged into this online activity learn so much and apply it. On our side, as part of the academy, I find it very beneficial and necessary in the conduct of field works by our faculty, and for sure, it will facilitate learning to our students. Since Eastern Visayas State University is a state university, fund depends on the government allotment. If funds warrant, we will consider it or in our budget. Lastly, may I extend my sincere thanks to the speakers, Mr. Yuan and Madam Kim, and also the organizers. Looking forward for a better collaboration between EBSU and your company. Good day and God bless us all.
Thank you, Dr. Pilapil, and thank you, everyone. We highly appreciate your attendance today. Feel free to visit the SuperMap website to get more information about the company. We also invite you to follow SuperMap GIS on Facebook, Twitter, and LinkedIn because we are constantly posting about the latest GIS trends and what SuperMap is currently up to. Again, thank you for attending this webinar. Expect your certificates in a few days via email. SuperMap will hold more webinars on more topics soon. And of course, we hope to partner again with EBSU. And for the students, we will also be having a GIS contest in the future, so be on the lookout for that. We will virtually see you soon in the next webinar. Goodbye and have a great week.